Today I want to do a little bit more on the set theory playlist, and I want to introduce probability. And to a lot of people that might seem very strange, like why are you introducing something that's completely different? But actually it plays there's a very big connection between them, and you'll easily see that once you dive a little bit into probability. You can very easily see these connections. So let me just give you the setup. So here I have a die and a spinner, okay? The spinner, just pretend it's exactly even, so you have an even chance on landing on either color. I really can't, you can obviously see that blue is a lot bigger, but just pretend that they're all the same. And this is my poorly drawn three-dimensional cube there. So basically, 6-sided die, just 1 through 6. So there's a 1/6 chance of getting either of those options, okay? So let's think of a combination. Let's do not just a simple combination like, oh, what's the chance of getting a 1 and a blue or something. Let's do something like, what's the chance of getting an even number, and we'll say like blue or something. Okay, so it's very easy to see, like, okay, if I asked you what's the chance of getting an even number, well, there are 6 numbers, 3 of them are even, so 3 out of 6 is a half. So that's it, and then blue is 1/3. It's very easy to see them separately, but what about together, okay? And this and, let me write it out explicitly. It's and, okay? I could have said or. Now the difference between and or is that if I said even or blue, what you should be thinking of is, okay, so the chance of getting something that's even or something that's blue, so that's like, okay, I could get an even number here and any other color, because it doesn't matter. If I'm saying just even or blue, then it's really just I'm asking for one of the conditions to be met. So I could get an even and a green, and that would count towards my probability. Or I could get a blue and an odd number, and that would also count towards my probability. Or, of course, I can get even and blue, that still counts with the or. So let me more concretely write what I'm talking about. So, or in math, and, well, let me just give you the two definitions. So we have and is just both conditions are met. No negotiations or anything, both conditions have to be met. Or is just at least one of the conditions. And so if I said even or blue, it would include everything that's, even and blue, as well as just even or just blue. So let's kind of write out like a little bit of a table here, and it's going to be a pretty big table, so give me a little bit and I'll write out the table. Okay, so here's my table. So I have all the possible combinations of the die, and then all the possible combinations of the spinner. So I have R1 just means if I get a red and a 1, okay? So let's see, so if I want an even and a blue, so that would, I'll just circle them, it's fine. So even and blue just means, okay, so everything that's even, which is this row, and this row, but they also have to be blue. So both conditions have to be met. And so it's going to be this blue, and then this 2. Their intersection is going to be here, okay? And then this blue, we see the 4, that's also even, so that works. And then we see blue, and then the 6 also works. So those 3 work. And notice how I said intersection. And it is what we're talking about in set theory, where you look at blue and 2, you see where those 2 kind of, this line and this line intersect, and that's exactly what we're talking about. So, and really just means, like the intersection. Intersection. Actually, let me write this over here. So it's the intersection. And so you might think, okay, well then or probably means the union. And that's true. It does mean the union. And so that would include everything that's at least one of those conditions. So if we're looking for even or blue, so then that's going to be this one, because this is even. It's not blue, but it's even. This is also even. This is also even. So it's this, and this. And then everything else that's blue also counts, because even though it's not even, it's still blue. And so you can see that you have a lot more circles there. Okay, So that's basically the interplay between intersections and unions with basic probability. And I really just wanted to highlight that. So let me just kind of investigate that a little more. And you can clearly see that if we have two sets A and B, that A union B is a subset of A intersect B is a subset of A union B, okay? And you can clearly see kind of just how I set it up, because in this, both of the conditions have to be true, like, you know, and then A union B, it's just at least one, you know, at least one of the conditions. So obviously that's gonna, A intersect B is gonna be included in that. And you can also see that with the Venn diagram. So A intersect B is just this portion, A union B is the whole thing, all of this. So obviously, yeah, it's going to be contained. And the times when they're equal is whenever the two sets are equal. That's whenever A union B is the same as A intersect B, if A is equal to B, basically. I'm not going to write that down, but that should be kind of intuitive to you guys. And I think I might, for the 6th video of the series, I might have like a little bit of a proof or something like that, probably related to this. I still have to think about that. But yeah, I just wanted to show you guys, I didn't necessarily care about what the answer was, but you can kind of see what the answer is here. But I just wanted to show you the ideas between set theory and probability. So I think that's all I wanted to say about this. So I hope you guys enjoyed. Thank you so much for watching, and I will see you in the next video. Bye guys.